Hello everyone, let us start with one another example of surface development. So here it is given that draw a plan and elevation of a cone resting on HP. So first of all we have to draw the plan and elevation of a cone which is resting on HP on its base. Show and them the shortest path followed by an insect moving around the cone and returning to the same point. The insect starts from a point on the periphery of the base. Take the diameter of the cone 80 mm and height of the axis 90 mm. So first of all we have to draw the plan and elevation of the cone resting on its base on HP. The diameter of the base circle is 80 mm and axis is 90 mm. So first of all we have to draw the plan and elevation of the cone. The base circle diameter is 80 mm, axis height is 90 mm, and it is resting on its base on HP. So first of all draw the plan in the horizontal plane because it is resting on HP. So it will give us the plan in the horizontal plane. So plan will be below the XY line. So first of all draw the XY line, then after draw the plan. The plan shows us the top view of the cone. So top view of the cone. So first of all draw the circle having diameter 80 mm to draw the plan. Then how to find the center of the circle. So the center of the circle will give us the elevation of the apex point of the cone. So this will be the elevation of the apex point of the cone. It is O. Now divide the circle into 8 equal parts. 2 horizontal and vertical diameters. Horizontal diameter will be parallel to XY line, vertical diameter will be perpendicular to the XY line. Then after divide the circle into 8 equal parts. You can divide the circle by measuring the angle of 45 degree on both sides. So divide the circle into 8 equal parts. So and give the name A, B, C, D, E, F, G, H. Now join this points of the periphery of the base to the apex point. So OA, OB, OC, OD, OE, OF, OG and OH are the generators. Now project these points on XY line A, BH, CD, DF and E. So this will be the base of the cone. Now measure the axis height. Make sure that the axis height is 90 mm. So measure axis height is equal to 90 mm perpendicular to the XY line. And mark the elevation of the apex point O dash. Now join this apex point O dash to the base or points of the base, that is O dash A dash, O dash B dash H dash, O dash G dash C dash and O dash D dash F dash and O dash E dash. These are the elevation of the generators, and make sure that the end generators O dash A dash and O dash E dash will give us the two length, because plan of these two generators are parallel to the XY line. So these two generators will give us the two length in the elevation. So this is the plan and elevation of the cone. Now this is the example of the surface development. So first of all we have to derive the basic surface development of the cone. So if you want to derive the basic surface development of the cone, draw a line parallel to this generator. This generator is this generator will give us the two length in the elevation as we have discussed. So draw a line parallel to this generator, that is this line. Mark here as A point and a line parallel to the XY line from apex point. So this will be the development of this particular generator OA. Then after to develop the surface of the cone, we have to unfold the cone, and if we unfold the cone it will develop the surface like this. So first of all measure this length, that is the true length of the generator. Give an arc. Like this. After giving an arc, measure this angle. Theta is equal to 153 degree. here we have find the theta by using this equation, 360 degree into small r upon L, and here r is equal to the radius of the base circle and L is equal to true length of the generator. So here we have measured the L, that is the true length of the generator over here, that is O dash E dash gives us the true length, and it is equal to 98 mm. So 360 degree into 40 by 90, so 40 is the radius of the base circle and 98 is the true length of the generator measured over here, and these two generator will gives us the true length, both are 98 mm. So theta is equal to 153. Measure this angle and now divide this angle, that is OA, this angle into 8 equal parts to show the development of the cone and development of the cone by using the generators. So here we have shown the 8 generators, so here we are going to show the 8 generators, but by dividing this angle into 8 equal parts. And if we want to divide this angle into 8 equal parts, we have to use the angle bisector method. So to use the angle bisector method, first of all let us take one arc length, how to bisect these angles. Now first of all measure more than half distance of this arc and give an arc from this point, and from this point it will bisect this angle and generate the generator OE. Now we have to bisect this angle, that is OAOE. So if you want to bisect this angle, give an arc from here 1 and from this point 2, so it will give us the bisector over here. So draw this line. Now again if you want to bisect this angle, give an arc over here from this point and this point, so it will give us the bisector over here. Now measure this length O to B and divide this angle into 8 equal parts and mark the points A, B, C, D, E, F, G, H, A. So this will be the basic development of the cone. So now we have to show the shortest, see the shortest path followed by the insect moving around the cone. So let us assume that one insect is moving around the cone and returning to the same point, and here it is given that the insect start from a point of the periphery of the base. So if the insect start from the point of the base and it will return to the same point by moving around the cone, and the length of or the distance that the insect move will be the shortest distance on the cone. So it is not easily understood, we cannot easily understand it like this, but if we see the development of the surface, it will also generate the path on the development of the surface. If an insect moves on the around the cone, it will also move around the surface development, or we can find the path on the surface development. So by using the surface development, let us see that starting from the base point, so these are the point of the base, and returning to the same point. So the shortest path followed by an insect in the development will be from A to A. You can see that this will be the shortest distance. So this will be the shortest distance on the development of the surface. So we can say that if an insect follow the shortest distance to moving around the cone, then the distance will be also shortest in the development. So from the development we can see that from A to A will be the shortest distance of the insect to move around the cone. Now we have to draw this path on the elevation and plan. So if you want to draw this path in elevation and plan, let us mark these points starting from 1, this is 1 at A, 2 intersection of this part to the generators, 4, 5, 6, 7, 8 and again 1. Now take these points, measure these points, that is starting from 1 will be at A. Now 2 and 8 will be on the same arc. This is 2 and 8. 7 and 3 will be on the same arc. 4 and 6 will be on the same arc, and 5. Now project these points on, so 1 on A, intersection point of the path to OB is 2. Use the roller scale. So this is 2 and 8, 2 and 8, 3 and 7, 4, 6 and 5. So you can mark these points by using these projections. So now mark these points. 1 over here, this is 2, 3, 4, 5, 6, because 4 and 6 on the same arc. 3, 7, 2, 8, and draw the freehand curve passing through these points. So this is the path followed by the insect around the cone, but we can see the half path in the elevation. If we want to see the full path, we have to project these points in the plan also. So let us project these points. So 1 will be over here, then after 2 and 8, so 2 and 8, 2 and 8, ignore these points, center points, 4, 6 and 5 over here. Now if you want to find this point 3 and 4 intersection points of, see, 1 over here, 2 and 8, 2 at OB and 8 at OH. So this is 1, 2 at OB, 8 at OH, 6 and 4, 4, 6, 6 on OD and 4 and on OF, 5 over here. And if you want to find 7 and 8, extend these points at the end generators. Let us take it over here, project these points downwards on the end generators, that is at OA. Here we have extended this point at OA generator, and now rotate these points. 1 and 2. So this will be point 3 and this will be point 7. Now draw the freehand curve passing through these points. It will be the path followed by the insect. It will be the top view of the path followed by the insect around the cone. So the shortest path followed by the insect around the cone will be like this. This will be the plan of the shortest path followed by the insect. This will be the elevation of the shortest path followed by the insect, and this will be the surface development of the shortest path followed by the insect around the cone. Now let us do one another example of cylinder. A cylinder 40 mm diameter and 70 mm height is standing on its base on HP. Let us complete the plan, elevation and the basic surface development of this cylinder. So up to this point, let us draw the plan and elevation of the cylinder and the surface development of the basic surface development, that means without taking the section. So first of all, we have to draw the plan and elevation of the cylinder, and here the cylinder is resting on its base on HP. So it is resting on its base on HP like this. So base is on HP. So first of all, we have to draw the plan and elevation of the cylinder. So this will be the plan of the cylinder, and the base circle diameter is 40 mm and height is 70 mm. So measure 20 mm radius on the router, draw the circle, divide the circle into 8 equal parts to show the generators of the cylinder, and make sure that in the plan there isn't any required to connect the point of the base and the top face to the center, because this is the cylinder, this is not the cone, so there isn't any need to find out the apex point. So this is the cylinder. Divide this plan of the cylinder, divide the circle into 8 equal parts to derive the generators, that is PA, QB, CR, DS, ET, FU, GV and HV are the generators. So this is the base circle having radius 20 mm, diameter 40 mm. Project this point, that is A, BH, CG, DF and E. So this will be the base. A, B, C, D, E, F, G, H will be the base of the cylinder. Now measure the exercise, it is 70 mm, measure 70 mm height, and at the 70 mm height, draw the top face by extending these lines and showing the generators. So AP generator, so this is P dash, Q dash, R dash, S dash, T dash, U dash, V dash, W dash. So P, Q, R, S, T, U, V, W will be the top face. So mark base and top face, and by connecting the point of the base to the top face, show the generators of the cylinder. Now after showing the generator of the cylinder, let us show the basic surface development of the cylinder. So if we roll the cylinder like this, it will develop the surface like this, and this length from A to A, this length will be equal to 2 pi r. This length from A to A will be equal to 2 pi r. So right now 2 into pi into 20, it is equal to 12.5 centimeter, 125 mm. So this length, right now this length is 125 mm. Divide this length into 8 equal parts, so to show 8 generators of the cylinder in the development. So now if you want to divide this length into 8 equal parts, draw an inclined line from point A, mark 8 points on this inclined line, that is 1, 2 of equal length. First of all, we have to draw an inclined line from point A. If you want to divide this line into 8 equal parts, inclined line method to divide a line into 8 equal parts. So first of all, measure 1 point, 1, 2, 3, 4, 5, 6, 7, 8 of equal length. Then after, join this last point to the end point of this line and draw lines parallel to this line from this point, 1, 2, 3, 4, 5, 6, 7 and 8. So it will divide this line into 8 equal parts. Now draw lines parallel to this line, this line, 1, 2, 3, 4, 5, 6, 7 and 8. So this will be the basic surface development of the cylinder. A, B, C, D, E, F, G, H, A. We are opening the cylinder from the generator AP. So AP, P, Q, R, S, T, U, V, W, and P. So this is the basic surface development of the cylinder. Now we have to show the cut section. So here there are two cut section is given. It is cut by a plane passing through a point 50 mm from the base. So from the base and inclined at 40 degree to HP. So one cutting plane is over here passing through 50 mm from the base. So first of all we have to measure 50 mm distance on the scale at the center over here, and we have to show the cutting plane inclined at an angle of 40 degree. So this angle will be equal to 40 degree. We have to show the cutting plane inclined at an angle of 40 degree and passing from a point 50 mm above the base on the axis. So this is 40 degree. Draw this cutting plane. Now first of all complete the development of this cutting plane. So this is the first point, 1, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, 8 dash. Because here we have two generators, here only we have one A, so PA is only one generator, so here 1, here 2, 8, 2 on QB and 8 on HW. Then after 3 and 7, 3 on CR generator and 7 on GB generator, 4 and 6, so 4 and DS generator, and 6 on FU generator, and 5 on ET generator. Now first of all develop this surface. So 1 is on generator PA, so project this point on PA generator in the part of the development PA. So this is 1, 1, 2 and 8, 2 on generator QB and 8 on generator WH. So here 2 and here 8, 7 and 3, so 3 on generator CR and 7 on generator GV, 6 and 4, 4 on generator ST and 6 on generator FU, and 5 on generator TE or ET generator. So this is 5. Now mark these points. So this will be the first point, 1, 2, 3, 4, 5, 6, 7, 8 and 1. Draw the development of the surface passing to these points, 1, 2, 3, 4, 5, 6, 7, 8 and 1. So this is the development of the cut section, which is inclined at an angle of 40 degree and passing from the point 50 mm above the base on the axis. So this is the development of this cutting surface. Now we have to show the development of this hole, and it is given that here see a through hole of 20 mm diameter is drilled at 35 mm above the base. So through hole is drilled at 35 mm. See, so measure 35 mm and drill a hole having a 20 mm diameter. So you can also show this hole by using the circle master. 10 radius, that means diameter 20 mm. So here we have to drill the circle. Now we have to draw the plan of this drill hole, and it is going to be hidden in the top view. Sorry, project these points in the top view. It is going to be hidden. In the top view. This hole is not going to be visible in the top view. So now we have to project this hole in the surface or in the development. So first of all, show the center, and the center will be on these two generators RC and VT, because here the center is on RC and GV generators. So find the center, mark the center at RC and GV generator projecting from over here. Now we have to project these 2 points, 1 and 2, over here. Again on RC and GV generator, and this point again on RC and GV generator. So we have projected this point over here and over here, this point over here and over here. Now we have to project these 2 points, and if you want to project these 2 points, we have to project it from the top view, or we have to measure it from the top view on the line of the center. So let us measure this distance P2H, or sorry, intersection of this point from, or we can also measure it from GV generator over here, this length. So we have a GV generator over here, mark this length 1 and 2, same length will be away from here, C to R on CR generator, these 2 lengths. So from CR generator, from the center, mark these 2 points and draw the freehand curve passing through these points. Will be the development of these 2 or this hole till 35 mm above the base, and the diameter of the hole is 20 mm. So this will be the hole in the development part. Thank you.